guys. Just listening to my Lady Gaga Sokotoa parody, my normal Tuesday night adventures. Welcome to another video covering some quiz material for Thursday. So in class, we started doing this quiz review. Let me remind you, it looks like this. It's like page 13 of the binder. And we got through a lot of it, but I want to just finish doing some of these solving problems with you guys. So I'm going to start with 13. Remember that the whole goal of solving trig equations is to get the trig part alone. So in this one, I'm just going to divide over the 16. So sine of theta is equal to negative 1/2 because negative 8 over 16 reduces to that. So now I just want to think about the unit circle and ask myself, where is sine negative 1/2? So if I fill out my unit circle, I would just look at it, or I could just think about the fact that sine is going to be negative in quadrants 3 and 4. And so that's going to be not 150, that's going to be 210 degrees and then 330 degrees. That is where sine is negative 1/2. All right. So that's the answer. Okay, and again, we're going to answer these in degrees for right now. All right, for the next one, I'm taking a look at this, and right away I'm seeing a tangent squared and a regular tangent. So that right there is a hint that I probably need to factor in this problem. Since it's not a trinomial, I'm going to try pulling out the GCF, which is just tangent of theta. I'm left with a square root of 3 tangent of theta. When I pull out the first tangent, I still have another one left with this. And then over here, since I pulled out the tangent, I have to do a +1. Okay. All right, so now what I'm going to do is take each factor and set it equal to 0 to solve. So tangent of theta equals 0. And I want to think about, where is tangent equal to 0? The way I remember this with zeros and undefines is that tangent's undefined on the y-axis and it's 0 on the x-axis. So this answer will be 0 and 180. That's where tangent is equal to 0. Now the next part, I'm also going to set equal to 0. This one's a little bit more legwork. So I'm going to subtract over the 1 and divide over the root 3. Now when I divide, let me just draw this here. When I divide the root 3 over, I get tangent of theta equals negative 1 over root 3. That rationalizes to negative root 3 over 3. So I have to think about, or I can just look at my unit circle, or I can think about, where is tangent equal to negative root 3 over 3. Tangent's negative in quadrants 2 and 4. Tangent is root 3 over 3 at 30 degrees. So those are my reference angles. And let's see, quadrant, did I say 3 and 4? Pregnancy brain. Tangent's negative in 2 and 4. I think that's what I said. But that will be 150 degrees. And that will also be 330 degrees. So there's my answers to those. All right. We should be good. Now, let's go on to the next one. All right, guys, so for this one, we want to get, we'll truck through. For this one, I want to get sine squared by itself first. So I'm going to add over the 1 and divide over the 4. I'm going to do that all in the same step. So I have sine squared theta equals positive 1 divided by 4. And now I'm going to square root both sides. When I square root a fraction, I square root top and bottom. And I do not want to forget to do plus or minus. So I have sine of theta equals plus or minus 1/2. So I want to think about, where on the unit circle is sine equal to positive or negative 1/2. So that's actually all the quadrants. There's going to be 4 answers for this one. Sine is positive 1/2 at 30. It's positive 1/2 at 150. And it's negative 1/2 at 210 and 330. So there's my answers. Okay, 2 more that I want to do with you guys, and then we'll call it a day. 16, I highlighted it because there is an identity involved in this, okay? This is just like the quiz. There is one with an identity. So when we think back to our trigonometric Pythagorean identities, we want to think about what can I replace sine squared theta with, or I can replace cosine, but the one that you actually want to replace is the squared. And the reason I know to do this, you guys, is because these two are different trig functions. There's one sine and one cosine. So if you can remember back to the identities, we know that sine squared plus cosine squared equals 1. So if I get sine squared by itself, then I can remember that sine squared theta is equivalent to 1 minus cosine squared theta. So all I'm doing is replacing the sine squared, since it's a different trig function than this one, with an identity so that now everything's in terms of cosine. And this will be a lot more helpful for me to solve. So what I'm going to do next, since I have a cosine squared and I have just a regular cosine, it's a hint that this may be a factoring problem. Since I also have constants, it's probably going to be a trinomial. So I'm going to rearrange this. Since this cosine squared is negative, it's kind of weird, but I'm going to move all of this over to this side. So I get 0 equals. When I add over the cosine squared, it's going to become positive. I will subtract over the 2 cosine theta. So I'm going to subtract that over. And then I'm going to subtract over this 1, which is going to combine with the negative 2. So that's going to give me a minus 3. Hopefully that wasn't too much of a shortcut for you guys. I just moved all of this over to the right. Okay, here we go. So now we got a factor. So I like to think of this as x squared minus 2x minus 3. That would factor, let's see, 3 and 1, it's got to be a negative 3 and a positive 1 in order for this to work. So I would get x equals 3 and x equals negative 1, but we're not solving for x, we're solving for cosine of theta. So now I'm going to replace the x's with cosine of x or cosine of theta. You could literally just throw a cosine in front of these. This one doesn't work. Okay, 3 is out of range. So this part has no solution. However, this part does work. So we want to think about where is cosine, or the x value, negative 1, and that's in one spot only. I don't know why I put a negative there. It's at positive 180. And that's the only answer to this one. Okay, so that one was tricky because we had to use an identity. I'll probably give you a hint on the quiz that you need to use an identity. It'll be very similar to this, so I would study it. Last one, number 17. This is nice because I don't have to use an identity because both of these are sine. So this looks like a trinomial factoring problem. Think of it as 2x squared plus x minus 1. So we want to factor. Factors to 2x and x, 1 and 1. Let's see. It's got to be a minus 1 and a plus 1 because this will be a negative x plus 2x will give me a positive x in the middle. All right, so let's solve. So we will get x equals a half and x equals negative 1, but let's replace these back with the sign. So it's sine of x equals 1/2 and sine of x equals negative 1. So where is sine? Positive 1/2. That's at 30 degrees and 150 degrees. And where is sine equal to negative 1? That is at 270 degrees. So there's 3 answers to this one. Okay, so that's really it, guys. This part 5, we're gonna cut that out of the quiz. So really, you just need to know numbers 1 through 17 from this quiz review. Reminder that your assignment today is assignment 5, okay, which is this worksheet, quiz 1 review. You can probably cut out these problems that have to do with those inverse graphs. Okay, but other than that, you should be able to do that. So practice, practice, practice. Look back over this worksheet. You guys will be fine. All right, we'll see you tomorrow.